Welcome everyone to large language models, introduction to large language models, specifically retrieval augmented generation. And then so as a quick overview, in this class, we're going to go over a couple of things. One, a quick introduction on large language models. I'm only going to give a really brief overview simply because there is a lot to learn about if you're really interested in how large language models work. Specifically, it goes into neural networks, transformer architecture, and I won't get into all of that. It's a bit complex. I'm going to give a quick overview on what it's like what does it actually do? And then the most of this workshop is going to be focusing on building a retrieval augmented generation system. And that's the second part we'll be getting to, and that's going to be the coding part we'll be doing. And you'll see that in just a bit. And after that, we're going to talk about embeddings. If you're unfamiliar with what embeddings are, this is also going to be a pretty quick introduction to what embeddings are, and then it is a key step towards how retrieval augmented generation work. Any questions so far? Now, before we start, can anyone tell me what do you think a large language model does? Or what do you know about large language models? It's everywhere, it's all over the place, right? Like you probably use it. I know you definitely use it actually. Any thoughts? Well, to put it simply, large language models are pretty much word predictors. You can really think of it that way, are word predictors. Formally, they are deep learning models that are pre-trained on a lot of data, and that's a key here. They're pre-trained on a lot of data, and and they can recognize and generate text. In essence, you can really think of them right here as word predictors, right? First of all, large language models are, you can consider them as part of a class called of language models. And what language models are these are models that represent or really understands natural language by predicting the next word in a sentence based on a probability. So here's an example right here, right? When I hear rain on my rooftop, I something in my kitchen. And then so what word is going to be generated here? And the model basically decides what word to generate here based on the probability of each word that could show up in this place, and then picking the best one. There are lots of different ways to approach language modeling. If you go into, I learned this actually in college courses. If you take natural language processing classes or you're studying on your own, there are lots of different probability models out there, like Markov distributions, etc. Language models, large language models specifically, uses uses neural language models, algorithms like recurrent neural networks and transformers. Again, these are really interesting concepts, and I won't go deep into them. If you're interested, you should feel free to ask these questions to me later on, or look into them by yourself. I think these are really fascinating topics. An example right here that I've pasted in the picture here is long short-term memory. It's a type of neural network, and what is beneficial about neural language models or neural networks as language models is, for one, they're more complex, so they can capture patterns much better. Like they're really advanced machine learning models that can capture patterns and predict stuff much better than probabilistic models. But one really interesting idea here is with long short-term memory neural network models, they have this thing called memory, right? And this basically helps in predicting what is the next word in the sentence based on all the previous words in the sentence. Like, it remembers what it's seen so far to predict the next word. So long short-term memory is a type of model that can be a type of architecture that can be used to predict language models. For large language models, however, they use something called transformers, and I will quickly do a quick overview of that in the next slide. Again, these are just different ways you can, make language models really. Now, so far, any questions? Great. I'll take that as a good sign. We have large language models. And what would you think about it? And I find this really cool, actually, that before we have language models, right? And you can think of language models as models whose task is to solve natural language processing tasks. What I mean by that is the model's goal is to, translate words, translate languages, or do sentiment analysis. Sentiment analysis is given a sentence, you're trying to see if the sentence is a positive sentence or a negative sentence, right? This kind of stuff. And then researchers found that with a language model, with a neural language model, specifically one using a transformer architecture, When they make that model really, 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 really big, they acquire emergent abilities. In other words, emergent abilities really just means abilities that weren't there before, but now that it's really big, it somehow showed up. A few examples of these are you've probably already experienced them when you use large language models in ChatGPT, right? Um, Instruction following as an example. If you tell ChatGPT to follow a certain set of instructions, it will do that. In context learning is something we'll be actually looking into very closely during retrieval augmented generation. The idea that language models can learn based on what you can learn in addition to the data it pre-trained on, in addition to the data that researchers fed into the model when it was training the large language model. If you give let's say ChatGPT a bunch of text as context or just information, additional information, the large language model can learn from this additional information you gave it to it, right? And so that's in context learning, learning from the context. It can have reasoning abilities, and I'm sure about when if you have a ChatGPT Plus, or actually just with the ChatGPT, the regular GPTs like GPT-4o now, you'll see that it has some reasoning abilities, right? Like you can ask it to explain its thought process while it's generating answers. You can ask it to answer problems like a math problems or science problems, whatever. It has this ability to do reasoning. It can also do calculations. Not that great. At least it wasn't that great before, like a few years ago. Whenever you think of, hey, can ChatGPT do additions or subtractions? It's not great. But now it's getting a lot better, right? And here's an example right here. This is from a paper I read recently. As you increase the number of parameters, or you can think that as the size of the model, researchers found that the accuracy of GPT at doing addition increases. I find this really cool, right? Language models, they're there for modeling languages, but then language models are used for like translation stuff. But then when you make it really big, it becomes very smart. Who knew, right? Any questions so far? Feel free to put in the chat by the way anytime. Um, I will answer them. Now, one last thing about language models I want to talk about before we get into the fun stuff is language models are built using transformers. I won't go deep into them. As you can see on the left side, it's pretty complicated. The main thing I want you to take out of this is basically what happens is, right, you have some sentences here. This is the input. You have sentences. And what happens is it goes through this is called encoding layer. It goes through this encoding process and a decoding process, and then it generates things word by word. It will generate the first word using the sentences, using the inputs, and then using that first word, it will go back right here. This output, I hope you can see my mouse. The output from the output probabilities goes back to the output on the bottom right side right here, right? And then the model will then use both the inputs and the last generated words, plural words, to predict the next word. And transformers are really great at doing this because they have this thing called attention, the attention mechanism that allows us to look at the entire sentence while generating the next word. Again, this is really, really, really high level, but I think really cool. Really cool at it. Really cool stuff. And if you're interested in reading more about it, I recommend looking at the post, the illustrated transformer. There's a paper called "Attention is All You Need." Yeah, the paper that proposed transformers was by Google called "Attention is All You Need." Pretty sure Google, but it's a really difficult read. So if you're interested in learning more about it, there is a post on. If you just search up the illustrated transformer, it'll tell you. All right, let's get into the main topic of today: retrieval augmented generation. So retrieval augmented generation is the idea that large language models can incorporate new information. Is a technique that enables large language models to retrieve and incorporate new information. All right, let's see. All right, if you're just joining in, we're now talking about retrieval augmented generation. We just quickly cover what large language models are. So large language models have a few limitations, and I'm sure you have experienced with them when you played around with ChatGPT. A few specific ones I've noted here that retrieval augmented generation counters are these three. For one, if you ask some really specific domain knowledge to large language models, it may not be able to find the right information in the pre-trained data, right? An example, I have some example. This is prompts I fed into GPT last night, actually. It was a model GPT-4o. Obviously, the more advanced the model is, the more accurate it's going to be because it has more information in it. But I asked like, what is Snowflake's reported liability listing their 2022 10K? It's a really specific piece of information. And then so it won't be able to tell you because it's specific. It doesn't have the right domain knowledge. Sometimes they can hallucinate, and this is something definitely no. It will just lie. I have no idea who this is, by the way, but I found this. This is a question I found from a large language model QA data set. And then if you ask the question, you'll notice if you search up the sentence right here, you'll notice this entire sentence is flat out wrong. First of all, this author has never written a short story called Overtime. If you look that up, I don't think this author has ever written this short story, much less this fictional character being from that short story. In this case, instead of telling you that the large model doesn't know, it just straight up hallucinates some information, right? And that's dangerous. And finally, a problem with large language models is it could be out of date. Suppose you have a question that's, very current, and then the model is trained up to 2023. Then it won't be able to tell you the information that's in 2025, obviously, because the model hasn't even seen the information yet, right? So these are some of the limitations of using a vanilla, I call it vanilla large language model, which retrieval augmented generation can solve. And you'll see just a bit. See the time. All right. So what RAG does is it answers these knowledge-intensive tasks. And what this really means is tasks that require specific domain knowledge. It answers these tasks by, first, you have a question, right? And then the RAG system will first retrieve relevant context from an external data source. And then using the external data source, it will append this context back into the entire prompt. We'll see this in action when we do the quick coding project. It will append the entire coding, append the entire, what you call it, a retrieved context into the prompt. And then the prompt will have the context retrieved plus your question so that the model can answer the question using the context it has retrieved, right? So this is the whole chain. You have a question, you retrieve some relevant information, append the information into your question, and get the answer that hopefully is much more accurate. So that's retrieval augmented generation. This is another overflow. This is from the paper Retrieval Augmented Generation for a survey on different RAG techniques, right? And then so first you have you start with as a user, you have a question. Let's say this is a question. The first step is you're going to break down that question. This is the data collection step, really. First, you have some external data sources, and then you're going to chunk the data source and store them into some vector storage. We'll go over what that is when we work on the notebook. So you store that into some database, and then you use embeddings to retrieve the relevant information from the vector store. Once you have retrieved the relevant information, as you can see right here, these chunks, these documents are supposedly, if you have made the system well, these chunks should be relevant to your query. You append these query into your prompt along with your question in this step, and finally feed it into a large language model to get the answer. And that's RAG, pretty straightforward. Any questions? All right, this is just a really high overview. You don't have to, if you're still a bit confused, that's perfectly fine, because things should clear up a lot more once you take a look at once we work on the notebook project. All right, so one last thing I want to talk about before we start working is embeddings. Is anyone familiar with what an embedding is? It's okay as well. Embeddings are I didn't expect you to actually, so I'm just curious. So, an embedding are representations of words or documents as numerical vectors. A key thing here is, suppose you have these chunks. A good example is right here. Let's say you have the question, who is the president of the United States? And let's hypothetically say the large language model doesn't know the answer. The model doesn't know the answer. It should now, like realistically, because it's like really smart now. But suppose it doesn't. RAG should help this problem by retrieving the relevant context to answer that question. But then, given this question, how do you get the right information from Wikipedia to append to your generator? And what we do here is we need to find a way to figure out what documents, what texts are more similar to your question or most similar to your questions so that these documents can be used to answer your question, right? That's RAG. and I use embeddings. Obviously, it's hard to just compare words. Like, how do you know how close apple is to banana? Right, by just looking at the words. So you can't really mathematically figure that out. Embeddings represents these words as numbers, as vectors. And because now they're vectors that live in the same space, you can now use similarity algorithms to calculate how close one word is to another, or how close one sentence is to another sentence. And that's the whole point of embeddings. How are these embeddings created? I won't go into them because it's also another really complicated subject that you can spend a whole lecture on, like a couple lectures on actually. But the main point I want to take out here is embeddings are basically ways to represent words, or in our cases, sentences, documents, as vectors, so that we can find similarity between them. Right, like right here, right? You obviously can see that the word man is much more closer to the word woman than to, at least based on the embeddings they have made so far here, and they are closer together. And you do that by looking at the similarity between their vectors. All right, hold on, there's a chat. Okay, someone asked a question. For embeddings, are third-party APIs like OpenAI or AWS a lot better than open source local host ones? Well, I personally, I think they depend on data. Like, first of all, if you use APIs from, if you use open, okay, first of all, it's just easier to use embeddings from OpenAI. I mean, they have a lot more data than you probably have if you create your own embeddings, right? And and you just call an API and you can use them. It's much more convenient than trying to train your own. And the problem with training your own is a big part of it is just data and how you train it, right? I'm sure if you if you know your stuff really well, you can make your you can make your embeddings really well as well. But it's just they have much more data and they can probably do a better job, seeing that they have much more resources at it. All right, one last thing before we continue. Here is this is a thing that Google made a few years ago, I'm pretty sure. And this is a vivid representation of an embedding. Keep in mind, however, that embeddings usually have many dimensions and you don't really know what the dimensions are. Like the vector here you saw earlier, this is not how embeddings actually look like. Like right here, we can visualize what embeddings are by saying, hey, a man has 0.6%, I guess 60% of living being, or negative 0.2 in feline. Realistically, embeddings have like hundreds of dimensions. And then you actually don't even know what these dimensions are. So you can't really visualize them. But Google, I guess, helps condense them into a 3D space that helps you visualize it. If you're interested, the link is productor.tensorflow.org. And it shows you what embeddings like for some of the databases they have. And this is some pretty old database, Word2Vec. All right. And one thing you can see here, like let's say you pick any two dots, the dots that are close to each other are going to be much more similar to each other. See another question in the chat. Is any IP privacy issue with integrating local data with OpenAI API? Well, if you send any information, I'm assuming, okay, if you send information to OpenAI, it's like to ChatGPT, it's like sending information to ChatGPT. If you willingly gave it to them, and I guess you forego all IP or privacy issues, like you're willingly giving it to them. Or I'm not too sure about the privacy issues actually. A couple ways I can answer this actually. One, if you send a message to OpenAI's large language models, right? Send a user API. It's basically like sending stuff in ChatGPT, and there will be the same privacy losses, but whether you're using the ChatGPT, I'm pretty sure. Another way is you can fine tune a model, and that is using the models they have. You add some more data on top of it so that they behave the way you want them to using your own data. And with that, I also am not sure about the privacy laws. You should look that up. But if you're really concerned about securing your own confidential data, I don't recommend sending it to OpenAI, like fine tuning your model on top of it, just simply because you don't know what they're gonna do with it. Like if it's really confidential, like if you own a bank or something, and this is some bank data, that's probably why they have their own. That's probably why they have their own system backend. All right. I don't know why I stopped sharing. It was the same screen. Any questions? Hold on. I just did something. I don't know what I did. hold on. This is not okay. It's like hold on. Sign up. Great. Let's begin on introduction to retrieval augmented generation. I made a notebook, and this notebook quickly breaks down what retrieval augmented generation is. Well, the code is already all filled in. Because then the big part of that is because we only have 1 hour, and then so what I'm going to do is I'm going to go over each step of retrieval augmented generation with you, and at the end of the workshop, I'm hoping you can make your own RAG system using your own documents, your own sources, and play around with it. Sounds good? I'm going to share this link with you. I'm going to put it in the chat. And then you can, if you want to use it, I'll show you just a bit how. All right, so if you cannot access a notebook, please let me know. But you should have access to a view-only copy of the notebook. What I mean by that is, let's see, I open this up in another account. Look at that, thank you. Let's see, open it up in another account. And then, right, you shouldn't have, this changes will not be saved. So if you want to use it, I think you can connect to it and then just press connect. This will connect you to a Google hosted server, and then you are going to be able to run all these codes. If you're unfamiliar with Google Colab Notebook, it's a very convenient way to share code with each other. And this acts basically like a Jupyter Notebook. And then you don't need to run anything on your computer. And then if you have the dependency installed, which you can install to the notebooks, it just makes sharing code a lot easier, right? If you want to save a copy of this, you'll need to make a copy. But if you just want to try it out and run the code I have, you can just press connect on the top right corner and start running it. For me, however, I'm going to go back to what I already had. It's right here. I'll give it half a minute or so everyone can open it
I have a
up.
question.
Yes, go for it.
So it says like pip install and then like OpenAI, whatever. Don't you have to pay for that OpenAI thing?
These are libraries, these are packages. And so you can install these packages whenever you want.
Wait, but I thought you needed to for like how down there it says OpenAI key.
Exactly.
OpenAI key. You have to pay for that, no?
You do need to pay for it. To use the packages, to call on the OpenAI APIs, like to call on their program to do completions, you do need to pay for it. For the purpose of this project, I'm sharing my API key with everyone. So first of all, don't share with anyone else. And then I'm going to be disabling this disabling this API key in like 30 minutes after the class ends. So for this project, you're going to be spending my money. Also, I really hope no one, send like 1 million tokens in the next 30 minutes, which actually shouldn't matter because I think I set a limit on the API. I don't think it will go up above a few dollars. But yeah, you will be using my money for the next 30 minutes, basically. Good question. Yes, you do need to pay for it. All right, let's begin. So first, you need to connect. Retrieval augmented generation, as I discussed earlier, the whole point of RAG is you're given a question. Let's say your question is, I like Star Wars, so you'll see the entire notebook right here is all Star Wars theme. Let's say you have a question on who is Luke Skywalker's father? And I hope you guys have all watched Star Wars before or like don't care about spoilers because Star Wars is a really old movie. And if you still haven't watched it, you should watch it. And I hope you'll forget this lesson. Or if you're watching it like this weekend, let me know and we can change the subject. You have like 10 seconds to do so. So let's say you have a question, who is Luke Skywalker's father? And hypothesis, theoretically, let's say the large language model you're querying doesn't know, let's say OpenAI did not feed their GPT model anything on Star Wars. So then let's say the model won't be able to answer your question. What do? You need to give the model relevant information to answer that question. It's like answering a question. It's like answering your classroom question. Like if you have a reading assignment and then you want the model to answer your reading assignment questions for you, you could just ask a question. You could just ask GPT, hey, who is Luke Skywalker's father? Or you can find relevant quotes from the movie, put it into the context, and then ask the question. And then you say, hey, who is Luke Skywalker's father? As context, I've given you all of the information from Star Wars. Answer the question for me using the information I've provided. The trick here is, how do you automatically grab the information? So first, let's install LangChain. You could build a RAG system of vanilla, like do it all by yourself, and only rely on OpenAI's API key, or only rely on OpenAI's API. For simplicity's sake, we're going to be using LangChain, which is an open source framework for developing large language models. It makes building RAG really easy. Like you'll see the code is just a couple lines really. But that's beside the point. And if you really think of building a big LangChain model, if you really think of building a big RAG model, I recommend using one of these packages. All right, let's get into it. Sorry, I'm talking too much. First, we need to set the OpenAI API key. This is going to be how LangChain is going to be calling the OpenAI API in their library, right? And again, this is my key. So again, don't share this with everyone. I am very serious about this. I am a broke college student and I need the money. And first, we need to initialize a large language model. We need to initialize the large language model agent. This is the wrapper class that LangChain uses to call on the OpenAI API. And then this is the format it takes. So to call on a large language model, at least for OpenAI's model, you need first initialize this. We're going to be using the GPT-4o mini model. And then you need messages. Messages are basically the input you give it to models. There's a system message. System message guides the behavior of the model. So supposedly it's right here, it's really generic. You are a helpful assistant. You can make this something like, you are a expert at Star Wars and you try to answer things in Yoda's tone. And if you say that, the model should theoretically answer your questions like Yoda does. They do everything backward, like backward, I say. Exactly. And then user message, and this is a prompt you usually ask ChatGPT. Right? And if you print this out, if you run this code, you'll see this is the GPT's answer. Luke Skywalker's father's Anakin Skywalker. Spoiler. So first, let's build RAG. And run the model, run the thing. You need these packages.
I have a question.
To work. Yes.
When I did the run thing, the run button, it said that module not found.
Oh, you need to run the first line first, the pip install line.
Oh.
All right. So first, for simplicity's sake, what we're going to be building is we're going to be building a vector storage on top of Wikipedia documents. And then LangChain provides a class called Wikipedia Loader that basically loads in documents from Wikipedia for you instead of having you to manually scrape them down and then load them in. I'm using this because I'm lazy. So right here, this Wikipedia Loader is a LangChain library that will collect the top 50 documents with a query Star Wars. And then for each Wikipedia page, it's going to collect 4,000 articles. As you can see here, it's now downloaded 50 documents once you run it, right? And if you run this, these are the documents it has collected. So first, the first document is called Star Wars, and then it has a summary, and it has this content. The first has this. This is the text it has downloaded. As you can see, it has collected this many. It has downloaded this many Wikipedia articles. The next step, once you have downloaded the documents, is you have to chunk the documents. What is chunking? So take a look at this text right here. This is a really long text. This has 4,000 characters. If you transform this text into some numerical embeddings, the embedding is probably going to be terrible. And the reason is just because there's so much information in this one paragraph. Like, let's say if you embed the word apple or you embed the word banana, right? Like the embedding is obviously going to represent the word banana or apple. If you embed this entire paragraph, like what the hell is a model? What is a model supposed to represent? There's so much different ideas in there, so much information. It just gets mixed up. So what we need to do is we need to make this into big, huge document chunked up. We need to chunk them into smaller documents, I call them chunks. Some libraries call them nodes or just smaller documents, whatever you call them. We need to chunk them. LangChain, again, offers us a package, API called the recursive character text splitter. There are lots of different ways to split a document. You can split it by sentences, like after every period you see, you split them. or you can split them by character length, like after every 200 characters, no matter what, you split them. Recursive character text splitter is usually the one you use. Like I'm pretty sure if you look up any libraries that any open source libraries that implement RAG, this is the most generic one because it tries to maintain a paragraph as close to each other as possible. And then it splits things first by paragraphs, then by sentences, then by words. So it will try to maintain as much of a sentence structure as possible. A few key parameters here is the chunk size. That's how many characters are in the chunk. Chunk overlap. That's an interesting idea actually. Let's say you have this document right here, right? And then let's say this is one chunk right here. But what if the chunk got cut off before the end of a sentence? Chunk overlap helps in that the previous chunk and the next chunk will somewhat overlap with each other so that it won't be abruptly cut off. It will still maintain some context on the previous chunk so that even if if one sentence is cut off from each other, it will still somewhat be connected because of that overlap. And feel free to modify these parameters. Like I can make this 512. Let's do 2048 for now. Let's see what makes this. It's 64. And you'll see that I've split this into less chunks. I've split 50 documents into 150 chunks. So far, any questions? Great. So far should be pretty straightforward. Next step is indexing the document. Now we need to store the document into a vector storage. And this is a two-step process. First, for each chunk we have, again, this is a smaller document, we need to transform them into an embedding, right? And we need to make them into numerical vectors, numerical representations. And then once you have these embeddings, we store them into a vector storage. A vector storage, you can think of them as basically databases. And whereas usually you would query a database by keywords, right? Or whatever filter you have. With a vector database, you will have the entire database is made of embeddings of vectors. And then for some question you have or some query you have, it will retrieve by finding the embeddings that are closest, like literally distance-wise, closest to the embedding you're querying from. Let's take a look. So first, using LangChain, you first need to create the embedding object. We're going to be using the cheap model because I don't have money. And actually, LangChain does the embedding stuff for you when you index them. So you don't really need this part 3a step. You don't need to do this. But I just want to show you guys what embeddings look like. If you run this code, you'll see that this is the chunk that I'm embedding, right? Star Wars is an American epic space opera, blah, 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 blah. And as you can see here, OpenAI made an embedding. This entire chunk got turned into this vector of like a really long vector of numbers. And using numbers, we can now calculate distance. Lots of different algorithms. Like I'm sure you've learned of the Euclidean distance, the Pythagorean algorithm. There's cosine similarities, all kinds out there. Now, this is the key step. Given the chunks, we take out the text and then we embed them. And as you can see, we now embedded 153 documents. Next step is we add them into the vector storage. Pretty straightforward. You create a vector storage called in-memory vector store using the embeddings object, right? And then you add your chunks, the documents you want to add into your vector storage, into the vector store. In this case, I've used a vector store called in-memory vector store, and this basically just uses Python's NumPy pipe library to calculate distances between embeddings. And then as you can see here, if you inspect this, these are like the top 10 documents you've added into your vector store. Okay, that's it. That is all you need to do. Any questions so far? All right. I'll try to wrap up the notebook in I think I have 5 minutes so that you have some time left to try to make your own RAG system. The final step is now that we have built this vector storage, we want to use it to retrieve context. So it's a 4-step process, really. You have a query. The first step is what is the question you want to ask? Second, you need to transform that query into a vector embedding. Same step as what you've done up here, right here. Where is it? Here, right? And then you create an embedding for that query, and now you use that query into your vector storage, and you find the top K documents that have the embeddings most similar to the query you have embedded, and they return these documents. That's it. So let's say we have a query called "Who is Luke Skywalker's father?" All right, now LangChain again wraps all this under the hood. You don't need to make you don't need to do the whole embedding transformation stuff. All you have to do is give me your vector store, call vector store.similarity search, and bam, you retrieve your documents. Right? And this is the top 3 documents you've retrieved that supposedly will answer your question. What it really means is these chunks are most semantically similar to your query using their embeddings as a way to calculate similarity. And if you, a few things you can change here, if you make top K like bigger, let's say make it 5, it'll retrieve more documents. Yeah. And now finally, the last step is now that you have retrieved the context, you just need to append that into your prompt, right? Recall earlier how we have submitted a message to large language model. You need the system prompt and you need the user prompt, user message. So here, what I did was I joined each chunk using 2 new line characters, and then I added them into this is the template I'm using, right? I first fed the context underneath I tell the model this is the context, and I have tell the model this is the question I want answered, and I want the model to answer the question. And this is basically what the text looks like, right? Like this is all the context the model is going to be using, and then I ask the model, hey, using the model, what is the answer to this question? And if you run this right now, you will see that it's going to be able to answer your question. And this time it answers your question not using model's memory, but it does so using the information you've provided it. All right, so that's a really quick rundown on RAG. Again, it's pretty straightforward once you understand it. All it really is doing is automatically getting the information that should help in answering your question to answer your question. That's it.
I have a question.
Yes.
So for the part where it's part 4, right?
Yes.
It says like query equals, for example, who is Luke Skywalker's father. When I run it, it works. But then when I run the next thing, it says name error. Like
Name error?
yeah, when I click run.
Okay. Can I take a look at that later once we start working on once we start working on the individual work part? I'll take a look at your code in just a bit. Is that all right?
Okay.
All right. Thank you. I need to think on that. And so a quick, any other questions before we move on? All right, great. Let's do a quick wrap up then. And so first of all, it's a typo, ignore that. First of all, LangChain offers a lot more capabilities than we have just seen. LangChain is a huge library. There's other RAG libraries like Llama Index. That's another one. I highly recommend looking into them. I think they're really fascinating. And now that large language model is everywhere, it's nice to know what goes on in the backend, like what happens when they retrieve context or retrieve documents, or if you want to build your own system. This is a really simple way of building your own large language model system. In fact, LangChain offers other cool stuff like agents and tool calling. So at least 1 year ago, I would say things are moving way too quickly now with AI. Most of building any large language model system really is RAG, right? Like there's a large language model doesn't know enough information, and then how do you improve it? You give it the information it wants, and that's RAG. Now it's even better. Now you can make the large language model think to itself and think, I have this question. Now, I don't know how to answer this question, but instead of using RAG to retrieve the context, the large language model is going to think to itself, I'm going to call on this tool to help answer my question. That tool could be RAG. It could be a vector storage, or it could be it just goes on the internet and searches for the information. It could be a calculating some things. So models can now, call on tools to help answer your query. It has agents. Agents are basically, you can think of them as coordinators, really. Like it tells you what tools to call on. Agents talk, they're like models talking to each other saying, oh, you have this question? I'm going to tell you how to answer this question. And to answer the question, you need to call on this tool, then this tool, then this tool, and do blah, 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 blah. All of this stuff, LangChain can help you to do with that. And a few more things I want to talk about before we continue. RAG, there's a lot of stuff that RAG can do. For one, like what we just talked about, but a lot of things RAG cannot do. And is that RAG really depends on the quality of the retrieved context. So let's say you found these documents, right? These are all documents on Star Wars. But suppose you found really bad documents. Like let's say you have a document on Star Trek, or you have a document on the planet Pluto. None is relevant to Darth Vader or to Luke Skywalker. In which case, the model will get misled because you've given the prompt some irrelevant information. So in this case, how you retrieve the document and making sure that your retrieved document is relevant to your prompt is very important. There are lots of different ways to improve RAG. Right now, what we did is like the most simple way, just similarity searches. You could improve it by using different recommendations for data storages. You could do different retrieval strategies, etc. And if you're interested in reading more about them, I'm happy to talk to you about it after class. Not after, just right after this. If you are curious to learn more about what are some different retrieval strategies you can do to improve your system or whatnot. Here is just putting all together. This is everything we've done. That's not right. Sorry, there's a typo here. This is everything we've done. I'm just putting it into one code. As you can see, it's pretty straightforward. And now I would like you, in the last 15 minutes, to try to make your own RAG system. In our case, what I did was I used Wikipedia's document loader to load in documents. You could do the same thing. And then you could, instead of loading in Star Wars documents, maybe you can load in a document on, I don't know, Star Trek, or load a document on Pokemon. Or what I recommend actually is finding your own documents. You can, so if you like find your own websites to scrape off, and then using the scraped website information, and then feed these scraped documents into your vector storage. If you're interested in doing that, actually, I can help you with those. And you want to use this tool that LangChain has called web-based loader. It makes it so that you don't have to scrape the document yourself. You can just ask LangChain to do it for you to scrape the documents. All I have to do is feed it the links you want to scrape. So that's this link right here. And then you can build your own storages. I recommend specifically for RAG to solve really niche problems. Because usually if you have a general question like who's the president, the large language model probably already knows how to answer that question. And then what's the point of making RAG? Something more niche, something that's your passion, maybe like a book you're reading or a movie you know about, or like a fandom page, or let's say the Pokemon index page. Something more niche that the model may not know about, but will benefit from this information, from filling in the information gap. I say that's where RAG really shines out most. And if you're too lazy, if you like me, if you're a bit lazy and you don't want to, scrape stuff and use other classes, you can also use LangChain's document loaders. The document loaders just makes downloading documents really easy, like a one-step thing right here, and then loading all the documents. Any questions? Great. I hope you have enjoyed the lecture. Well, not lecture, workshop, sorry, workshop. Yeah, 15 minutes, have fun. If you have any questions, I'll be here. And then I'm excited to see what you've built if you decide to build something.
Wait, how are we supposed to do this?
What do you mean?
Like, I'm kind of confused.
So, right. It's a good question, actually. Let me elaborate a bit more. Basically, your this right here, this code right here is what the RAG system is, right? As I've broken it down, you want to load in documents, chunk the documents, index the documents, retrieve documents. All of this stuff is the code right here in the previous cell. You could just copy paste and just modify a few things, like modify what the load is, or make your own. That's it. I recommend building this in reference on what I just discussed earlier on. Does it help answer the question?
Also, you said you would look at my...
Yes, let's do that now. All right. So if no one has any more questions, let's see how I can do this. Let me stop sharing. Also, before I can do it, I saw a few more people join in like way later in the class, way later in the workshop. I will put the link to the, hold on again. I'll put the link to the Colab notebook if you're just joining in again, if you don't have it earlier. All of the stuff I've covered so far is you can really find them in the notebook already. So if you're just joining in, feel free to open up the notebook and take a look at it. And I don't know your name. Sorry, you have your initials on it. Do you want to just share your screen now, or would you rather like open up
I guess.
a room for you to do this?
Uh,
Let me open up a room. It's probably easier.
it's wait, so you want me to share my screen so you can see what you want?
He's gonna put you in a room.
Oh,
Yes. So let me see if I can do that actually. Okay, while I figure this out. So William asks, what is the Ubuntu command to download link chain? I just use pip install. Pip install makes everything easier. I think it's also just pip install. Right? Like you're not downloading softwares. You're downloading Python packages. And pip is like the installation manager for that. If you use Anaconda, you can also use conda install, and that also works. Can I make rooms? What the? Oh, here we go. All right. Let's see. Room 1, 2. Okay, I've made 2 rooms. If any one of you have questions that you don't want to ask questions in the open, I'll just join a room as well, and then I will be there. I'll check out the room, and then I don't know your name. Join room 1. I'll meet you there. Great. All right. One last warning: don't use up all my credits, please. Thank you. All right, I see more people joining in now. I'm assuming there's another workshop coming up. Is there? I'm not sure. Uh, 1:30. Thank you. But 1:30. What time zone? Because it's 1:58 right now for me. I'm at Eastern time. PST. All right. Thank you. So I think I have 30 minutes. But I'm good. I'll be. And this workshop ends at 2. Um, let me get everyone back to the same room first before I make announcements. The rooms.
is the thing ending?
Yes, but I'll still be here for like a couple of minutes or 10 more minutes.
I was reading the web beta loader thing and I'm completely confused.
All right, I can help you out with that just in just a bit. All right.
All right.
Okay, so thank you everyone for attending this workshop. And again, if you're interested in learning more about RAG, feel free to reach out to me. This is my email. I will put it in the chat. And feel free to keep a copy of the notebook, by the way. It's a pretty good template for building your own RAG system. It's a really simple one. And however, I do want to warn you that the API key that's in there will go invalid in about 15 minutes because, again, I am really broke. So if you want to make your own RAG system, you'll need to register for your own API key model. Sorry, you need to register for your own API key. You can do that here. If you just search up OpenAI register for API key, it'll tell you. But I'll put the
Gemini API keys are free.
What API keys are free?
Gemini.
Oh, okay then. You can also use Gemini. But if you use Gemini, you're gonna have to modify the large language model you use. Right now, the large language model we're using is OpenAI's. A few years ago, actually, they made it so that if you register for the first time in OpenAI, it's free. But I think that Jay changed it. All right, that's it. If you have any more questions, feel free to stay after, and then I will be here to answer any more questions. If not, again, thanks for coming. And I should stop. I can't stop recording. All right. Thank you. All right. If you're still here, I'm assuming you have any more questions.
Well, I mean, I read the web-based loader thingy, and I'm completely confused. So, like, I'm probably not gonna end up understanding that.
Okay. I can do a quick rundown on it, actually. I'm more than happy to.
What's your reason?
Let me open this up.
Said it anymore.
Let me open this up. Let's see, it should be here. All right. This is a documentation for web-based loader. And yeah, I say reading documentations can be tough, honestly, but this is a good skill to have in general, when you're later on working on your own project. Documentation are generally like the best place to figure out how to use library, simply because it's what should I call it? You can't go wrong with it. Like, this is specific. It tells you how you use something. In this case, I recommend just following the instruction line by line. So first, according to the documentation here, so what web-based loader does, if you read this right here, is suppose you have a web page. Let's say, I don't know why I'm filled with the Pokemon stuff, but let's say you want to scrape the Pokemon Wikipedia page. Okay. Let's see, what is Pokemon Wiki right here, right? You have this document right here, and a web page is filled with HTML information, and this is a web page itself. So, what this web-based loader is hopefully going to do is you feed it some link, and it will be able to get you the information, load you the document by scraping the link by itself. Let's say we want to load this link right here. Let's pick FutureHacks, do a Pokemon. Yeah, let's do Charmander. Why not? I want to scrape this website, this Charmander thing. Following the instruction, you first need to install relevant packages. You need to download Beautiful Soup 4. So let's just copy that here. First, need to install these packages as per the instruction. And then just initialize it like this. Do this one. Right. Okay. And then you load it. All right. So this class supposedly will load all the documents you've added here into a class called loader multiple docs. And then afterwards you need to call load to use it. Let's do another document.
Wait, what happens after it's loaded?
Then you can use it. Let's take a look. Then suppose it loads correctly, right? If you load it, you get this variable docs. Docs will be a list of documents, and you'll be finishing this step right here. Here, you know how I use Wikipedia loading documents? You're basically using this web-based loading documents, and then the rest of the code will be the exact same. You can change some parameters, like you can make the chunk size bigger or smaller, split the documents differently, use different vector storage. But this step right here is just a step right here, like loading in the documents. See if it works. I hope this works. Again, this is because you're not using your own scraper. I cannot guarantee how effective this is. You're hoping that the LangChain library does a good job at scraping stuff. but I bet it will do a pretty good job. Yeah, it does. As you can see right here, it scraped the document for Charmander. It's a bit scuffed simply because, it's a website and then website information is unstructured, but here it is.
Wait, but after I have that, don't I want to be able to like pull information from that?
What do you mean? Like
Well, like the RAG system, for example, well, instead of having your RAG system or whatever, you get that thing, but then you have to do something with it, right?
Yes, exactly. Now that's up to you now because you have the documents now right here. This is the stuff you've done, right? You made a docs variable, right? And that contains the list of the documents from these links. That makes sense so far?
Yes, but after you have them, don't you want to be able to use them? How do you use that thing?
That's all the stuff below the step right here. Like everything, all the rest. You can just copy paste if you want to.
Okay.
Or you can, do your own.
Thank you, Daniel.
No problem.
Yeah, thank you.
Is there a way to remove junk like link headers and footers from PDF documents before giving to the AI? Yes, but okay, I was going to say it's up to you to remove them, but that's probably wrong. Let's take a look. I think LangChain has a way to do with PDFs, just because, of course it does. I am right. You can use LangChain's PDF document thing to load in PDFs. Yeah, just use this. I'll put the link in the chat. In general, you want to clean the documents. If you take a look at this right here, right, like the document I loaded in, it has a lot of these escape characters. And it makes sense because a website like this has all these random information that you don't really want. And so you want to be able to deal with that, and then you want to clean them out. If a library and third-party library you use, like the one I use right here, web-based loader, doesn't do the job you want it to do, suppose let's say the PDF loader I just sent you, it doesn't remove the headers as much as you want it to remove, then you want to remove them yourself. And the reason you want to remove them is, like you said, what if the retrieval augmented generation system, it retrieves these irrelevant information and put it into large language model. And these noise can sometimes affect the model's performance. No problem. You too. Have a nice day. Thank you for coming. All right. I'm sorry if I'm pronouncing the name wrong. Bumika, I think. Do you have any questions? All right. If not, I'm going to end the meeting right here. I'm assuming you are AFK right now, but you have about 20 seconds to correct me. All right, that'll be it then. Thank you for joining. Thank you for joining. And for anyone who's still watching the recording, thank you for joining. Goodbye.